Hello students, so this is our next video tutorial on the chapter laws of motion. In the previous chapter also we have solved some numericals, still some numericals are left, so you will try to solve, and the leftover numericals I will be conducting one video. In that I will solve all the other problems which you are facing, doubts, questions I will be solving once more. So let's start today with new chapter, laws of motion. So before going to this chapter, let's learn what is the meaning of motion. So motion is an external agency which can make an object move, or which can stop a moving object, which can change the direction, which can change the shape, it can change the dimension. Now shape, when I say, means dimension, length and breadth, it might be changed. So when you apply a force, these effects can be seen. So force is a cause of a motion. So without force there won't be any motion. Now Newton's first law of motion states that an object at rest remains at rest, an object in motion remains in motion until and unless an external force is applied. So we will see what are the different types of force. Now forces can be contact force, forces can be non-contact force. Like when I say contact force, now let's start with here. You see contact forces. Contact forces can be of normal reaction, frictional force and air resistance. Now let's understand each and every term very detailedly. You see, normal reaction, what does this mean? Suppose on a table there is one block weight is acting downwards. This is the weight which is acting in downward direction, and this ground is exerting a force in upward direction. That is the reaction force, right? This is the reaction force here. So this reaction force is known as normal reaction. Okay, so when I say contact forces, the forces which generates when there is a contact between, you see, there is contact between source and the object. So this is a contact. You see, when I hold any string, that means there is a contact between my hand and the string. So when I pull that string, that is the contact force. So contact force means here two objects is required which are in physical contact. Here you see this block is placed on the table. So let us consider this is a table, and on the table when this block is placed, the weight is acting in downward direction and the reaction force, that is the normal reaction, is acting in upward direction. So there is a contact between this block and the table, and the table is exerting a force perpendicular direction, that is in upward direction. So this is known as normal reaction, that is denoted by Fm. And force is a vector quantity, so we know any quantity which is vector, we will be placing an arrow in the up head. Next we have frictional force. You see, whenever any object is sliding on the ground, a frictional force acts in backward direction and the applied force acts in forward direction. If this block, same block, if I apply a force in this direction, that is in forward direction, a frictional force will be acting in backward direction. Now to find the net resultant force on this block, we have to get the resultant of this force and this frictional block according to a diagonal. Like you see, as I have said, this is the force and this is the frictional force, and the object weight is acting downward, it is exerting a reaction upward, so its resultant force will be this, that is F contact. Okay, so this is the resultant force of frictional force and applied force. So this one can be drawn here also, then it will give a same magnitude. So F contact, so what is the formula? That is, you see, F square plus R square plus 2F R cos theta, right? So this is the formula. You see, this force square of this force square of this force must be equals to or plus 2 Fr cos theta. Now what is the theta here? The theta is here 90 degree. That means the frictional force and the normal is making a 90 degree. That means if theta is 90 degree, then cos theta, that is cos 90, equals to 0. So our formula will remain as F contact equals to F square plus R square. So next we have air resistance. This air resistance comes into play when there is a friction between a moving object and air. So whenever any object is moving in air, so there will be an air resistance that is given by Fa. So this is also a contact force, that is a contact between this air and the moving object, right? So next we have non-contact forces. So non-contact forces are those forces which comes into play when there is no contact between the source and the object. Like you see the gravitational force, the objects are, the masses are very far from each other, like the sun and our earth, the planets. So there is a distance gap between this source and an object, but still though there is a gravitational force exerting between each other. So each planet is exerting force on other. So there is no any contact between the planets. So this comes under non-contact forces. Similarly, the electrical forces which arises due to charges, due to flow of charges. So charges may attract each other, charges may repel each other. Like two positive charges will always repel each other. So never they will be in contact, they will be repelled, but they are exerting force on each other. So this is called non-contact force, right? Gravitational force, electrical force, and next we have magnetic force. So same thing with the poles of a magnet also. North pole and north pole both are exerting force on each other, that repulsion force on each other, but they are not in contact. So there is no physical contact between the two bodies and they are exerting force on each other. So this comes under non-contact forces. I repeat, contact forces are those forces in which there is a physical contact between the source and an object. Non-contact forces are those forces where there is no physical contact between the source and an object, and it is a field force. That means there is a distance between the two bodies. So in the screen you can see there are bodies connected with strings. So when the bodies, like here masses, they are connected with your string, and here one pulley is also connected with a string connected with the two masses. So you see here, string can be inextensible string, it can be massless string, it can be not massless string. So this all affects the tension on the string. That means the force on a string is known as tension. When two bodies are connected here with a string, that means each body will exert force on each other. So that force, they are exerting each other on the string with a name called tension. Okay, so tension is nothing but a force which is exerting one object on another. Here also you see two masses are there, one is in terms of small m and one in terms of capital M. That means both the masses are hanging with a single string passed over through a pulley. So these masses are exerting force on each other through a single string with a force called tension. Now in case the string is inextensible, now inextensible means here, that means the length is not increasing, that is string length is same. The same tension exists throughout the length of the string and system moves with same acceleration. What does this mean? If the string length is not increasing, then it will exert in each and every length of that string with same force, that is the same tension. Similarly, it will show over an horizontal surface while shows motion across a pulley. That means it doesn't matter whether it is being placed on a flat top table or it is passed over a pulley. In all the cases the tension will be same. Now in case of string massless, that means if the string is massless, it is not having a weight, the weight is very negligible, then in that case also this tension will be different, parts will be same. That means each and every different part, that means of that string, there will be a same tension acting. That means T will remain same. But you see in this diagram T1 and T2 and T2, that means T2 and T1 is here, two forces are different. Here you see only T and T, that means same force is exerting here. Here also T and T, that means same force. Here also T and T, that means these are massless string. But when the string is not massless, that means the tension will be different at different points, right? So this mass is connected with this mass through a pulley. That means as the string is not massless, that means tension exerting here and here, it is different. That means both the masses are exerting different tension to each other, right? So string passes over a pulley. The string passing over a pulley gets divided into two segments. You see here, this is one segment and this is one segment. That means it is getting divided into two segments. The tension in these two segments depends whether the string is massless or not. If the string is massless, then the tension will be same. But whereas if the string is not massless, then the tension will be different at different point, right? So this thing you have to note. Next you see string massless means if the string is massless, then there is no friction between the string and the pulley, so tension in different parts is same. Now why it is so that if the string is massless, then tension is same? So here reason is given here. So this question comes, this note comes in a question, like give reason question, that why this string, a massless string, provides a same tension on each and every point. So answer, your answer will be, if the string is massless and there is no friction between the string and pulley, tension is different parts of a string is same. If there is friction between string and pulley, tension is different. That means if there is friction, then there will be a tension force in each and every point, but if there is no friction, then the tension, that is the force, will remain same, right? So this was all about massless string and non-massless string. Now when the bodies are connected with a string, you see here one diagram, and the string here, a spring is connected here with one mass. Let us consider at this end there is a mass being connected. It is being denoted by a dash line. Now when you stretch the mass and when you leave, the string will keep on swinging left to right. That means there is a restoring force exerting on that spring. I repeat, suppose if your mass, if you are turning it to right hand side, that means a force on the string will try to attract that force. So that force is called a restoring force, right? So that will be always exerting in opposite direction of your applied force. So that is given by spring force, that is called spring force or elastic force. So F is directly proportional to X. So X means at what displacement you have taken that mass. If the displacement is more, then restoring force will be more. If the displacement, if you have moved that object very less, then the backward force, that is the restoring force, will be less. Now if this proportionality sign goes up, we will get a minus sign, because you see the displacement and the restoring force both are in opposite direction. Okay, so in which direction the mass you are taking, restoring force was acting in backward direction. So for that reason there is a minus sign here, and K is called spring constant. Okay, and F is the restoring force. So spring constant of a spring is defined as the magnitude of restoring force due to a unit displacement of a spring. You see here, what was the formula here? Formula states that F equals to minus Kx. Now if this restoring force is 1 Newton, let us consider here 1 Newton, or make that displacement here, the displacement of that object which is connected with the string, let us consider that is 1 unit. If x is 1, then F will be equals to K, that is, or K equals to minus F. Minus is just the direction. Okay, that means this shows that the restoring force is acting opposite to the displacement of that object. So if I take only the magnitude, that means only the value, if x is 1, then K will be equals to F. That means spring constant equals to restoring force. So that one only it is being explained here. You see, spring constant of a spring is defined as the magnitude of restoring force. That means F equals to K due to a unit displacement of a spring. That means if x is 1, then F is equals to K. Just we have to take the magnitude. You see here modular sign is given. This is called absolute value. That means negative will become positive. Okay, just we are taking the magnitude. Now the forces can be balanced and unbalanced. When we say it is balanced force, that means both forces are equal and opposite. Like you see, a block is on the table, it is exerting a weight in downward direction, that is towards the earth, and the earth is also exerting a force on upward direction. Now when I say earth, that means the table, okay, that is table is exerting a reaction force in upward direction. So both the forces are balanced. You see, reactional force, that is normal force, and the weight is balanced, so this is called balance force. Similarly here, the car is also balanced, that means reaction force and weight is same. But there are some conditions where the forces are not balanced. So when the forces are not balanced, that means the object will move towards a direction where the magnitude of force is maximum. Like you see, if you are pushing one table, this table will displace according to the direction of your force. That means if you push the table on forward direction, the table will also move in the forward direction. That means because the table is lighter than you. Okay, so that is the unbalanced force. So you see, balanced force means a body remains at rest. When a body is at rest, then also we can say that it is balanced force. A body in motion moves with uniform velocity. That means if the velocity is same, then acceleration will be zero. So uniform velocity means zero acceleration. So in that case also we consider it to be as balanced force. That means if an object is at rest, then also it can be said as balanced force. If an object is at motion, provided with the velocity is uniform with zero acceleration, then also it is balanced force. Now unbalanced force can be of speed may increase. Now if the speed is changing, either it can increase or either it can decrease, and its direction may change. So if these three conditions are taking place, then we say that forces acting on that object is unbalanced. So this was all about balanced force and unbalanced force. So next we have momentum. So by having a simple look at a body, we can tell whether it is moving or not. How to make an assessment as to the amount of motion content in that body. So what is saying here, so when you see an object is changing its place from one point to another with respect to time, then we can say that object is in motion. But when that object, two bodies are in motion, so how to calculate which object is having high speed and low speed? So that can be calculated. The configuration of that can be easily find out by momentum. By understanding the momentum of both the bodies, so we can actually say the amount of motion contained in that body. So how much motion is contained in a body is calculated by momentum. So momentum depends upon two factors, that is mass and velocity. So linear momentum, that is denoted by P equals to mv, where m is mass and v is velocity. So whenever I say what is momentum here, so it is the product of magnitude of mass and velocity. Okay, that is a product of mass and velocity. It is written here also. So CGS unit, we say that is gram centimeter per second, that is gram for mass and centimeter per second for velocity. Similarly, when I convert it to SI unit, what is the SI unit of momentum? That is kg meter per second, that is kg for mass and meter per second for velocity. Okay, so this is a very important topic, that is Newton's first law of motion, that is a law of inertia. So first law of motion is also known as law of inertia. So what does it say? That when an object is at rest, it continues to be at rest. When an object is at uniform motion, it continues to be in a straight line until and unless it is compelled by any external force. So when, if you don't apply a force on any object, that object will not move. Similarly, if an object is in motion, if you don't apply any force on that object, then the object will not come to rest. So this is the meaning of first law of motion. And law of inertia, that is inertia is an inherent property of an matter which has an inability to change its state of rest or motion by itself. That means an object will not change itself, its state of rest or motion by itself. That is because of inertia, that is inability condition of any object. So when I say here inertia, so it is a property of all bodies by virtue of which they are unable to change their state of rest or uniform motion in a straight line without the help of an external force. So force is a cause of that motion. So without you applying any force, then that object will not move. So because the object has inertia, and inertia depends upon mass. An object with having heavy mass will have more inertia than an object having less mass. Okay, so heavy object will be moving with high momentum, and the lighter object will be moving with less momentum, because again momentum depends upon two factors, that is mass and velocity. If mass is more, momentum will be more. If velocity is more, momentum will be more, right? But mass and velocity, they are inversely proportional to each other. If mass is less, then the velocity will be more. So that is a practical view. You see, if you take a small stone and when you throw it, you'll find that small stone is thrown with higher velocity, but when a heavy object is thrown, it will move a shorter distance with less velocity, right? Though you are applying a same force on both the objects. So this features it, or these factors depends on momentum. So those who have not got the book, I will be giving you the PDF file also, so you will make a note on your exercise book of all the topics which I have taught, right? All the topics like the balanced force and unbalanced force, that means connected, the body is connected with a spring, that is elastic force, the body is connected with string, and the contact forces and non-contact forces. So all the notes I will be giving, so you will be writing in your exercise book.